Okay, section 5.4, we're going to look at the sum and difference formulas for the trig functions. We'll use the sum and difference formulas to evaluate trig functions, to verify identities, and also to solve trig equations. So let's jump right in. Okay. Alright, here's a list of the sum and difference formulas, so you're going to want to make sure that you get those jotted down in your notes. Notice that alpha and beta just represent two different angles, so we're looking at the sine of the sum of two angles rather than just a single measurement. So let's look at the first example. Okay. Cosine of 75 degrees. Well, we want an exact value. Since 75 isn't one of our special angles, we need to try to represent 75 as the sum or difference of some angles that we know. So we could rewrite the cosine of 75 degrees as the cosine of 45 degrees plus 30 degrees. Okay? And then we can apply the formula for the cosine of a sum. So we would have cosine of 45 degrees. Actually, let's back that up a little bit. So we need some more room there. Cosine 45 degrees times the cosine of 30 degrees minus the sine of 45 degrees times the sine of 30 degrees. So notice that the cosine of a sum is going to have a difference in the middle of the formula when we go to the substitutions. Okay? So now we just put in those values. Cosine of 45 is square root of 2 divided by 2. Cosine of 30 is square root of 3 divided by 2 minus sine of 45 times sine of 30. So one thing that you'll notice is you're going to need to know, you're still going to need to remember those values for those special angles, those things from our charts. So when we multiply, we have square root of 6 over 4 minus the square root of 2 over 4. So square root of 6 minus square root of 2 divided by 4. Okay? And that is equal to the cosine of 75 degrees. Okay? Next problem. Find the exact value of sine of pi over 12. So again, I need to write pi over 12 in terms of some of my special angles. So what I'm going to do there is I'm going to kind of think about, okay, I've got pi over 4. How would I write that in terms of twelfths? Well, that would be the same as 3 pi over 12. And if I look at pi over 3, that would be 4 pi over 12. Well, 4 pi over 12 minus 3 pi over 12 would give me pi over 12. So I'm going to rewrite the sine of pi over 12 as the sine of pi over 3 minus pi over 4. Okay. So make some more room here. Get rid of those. We don't need those anymore. So if I go to the formula, that would become sine of pi over 3 times the cosine of pi over 4 minus the cosine of pi over 3 times the sine of pi over 4. So notice they're just swapping from one side to the other. Okay? And then I put in their values. The sine of pi over 3 is square root of 3 divided by 2. Cosine pi over 4 is square root of 2 divided by 2. Minus cosine of pi divided by 3 is 1/2. And sine of pi divided by 4 is square root of 2 divided by 2. So now I'll just multiply them together. Square root of 6 divided by 4 minus square root of 2 divided by 4 gives me the sine of pi over 12 equals the square root of 6 minus the square root of 2, all divided by 4. Okay? An exact value for an angle that isn't one of our special angles. Okay? Problem number 3. Find the sine of u plus v when the sine of u is 4/5, and u being between 0 and pi over 2, so that's first quadrant, and the cosine of v equals negative 12/13, where v is between pi over 2 and pi, so that's in the third quadrant. Okay? So what I'm going to have to do, since I know the sine of a sum I'm going to have the sine and the cosine for both of those. I need to figure out the cosine of u, and I'm going to need to know the sine of v. Okay? So I'm going to start with u. Okay? U is in the first quadrant. Okay? So I can think of it in terms of the triangle and the sine being opposite over hypotenuse. Or I could think of sine as, remember, being y over r, and use x squared plus y squared equals r squared. Okay? In either case, I should be able to figure out what the cosine of u is going to be, what the x value is. Okay? So I can use x squared plus y squared, which would be 16, equals r squared, which would be 25. So that's going to give me x equal to 3. Okay? And I would get the same thing over here if I were to use Pythagorean theorem. That would be my x, so I'd have x squared plus 4 squared equals 5 squared. Notice I get the same equations right here in the middle. Okay? All right. So if x is 3, okay, then I know that the cosine of u is now going to be 3/5. Okay. In working with v, okay, remember cosine is x over r, so that means I'm going to have x squared plus y squared equals r squared. And when I solve that out, I'll get y equal to 5, which means that the sine of v is y over r, which is 5/13. So all those things from that chapter 4 kind of coming back into play here in chapter 5. So if I want the sine of u plus v, okay, then that means I'm looking at the sine of u cosine of v plus sine of v cosine of u. Okay? So, sine of u, that's 4/5. Cosine of v, negative 12/13. Plus sine of v, which is 5/13, times cosine of u, which is 3/5. So I've got negative 48 over 65 plus 3 times 5 would be 15 over 65. So if I take 15 and I subtract the 48, what am I going to get there? Negative 33 divided by 65. Okay. And that is the sine of u plus v. All right. Next problem. Similar. Cosine of beta minus alpha when sine of alpha is 5/13 in quadrant number 2 and cosine of beta is negative 3/5 in quadrant number 2. Okay. So again, if I think about cosine of beta minus alpha, okay, then that's going to be cosine beta cosine alpha plus sine beta sine alpha. So I need to know what those values are, because right now I have sine of alpha, right, and we know that the cosine of beta is negative 3/5, but we still need to figure out cosine of alpha and sine of beta. So we're going to go back to using those properties from the last chapter, from chapter 4. Remembering that sine is y over r, so I got x squared plus 25 equals 169. So we're going to get x equal to 12, which means cosine of alpha 12/13, but we're in quadrant 2, so it's going to be negative. Okay, so I can fill that in down here. Cosine of alpha, negative 12/13 plus, and I can come over here. Remembering cosine is x over r, so I'd have 9 plus y squared equals 25, which means y is going to be 4 and second quadrant, so sine of beta is positive in the second quadrant, so that's 4/5. So I can fill that in now. Okay. So now I just multiply these together, so that's going to be 36 over 65 plus 20 over 65. So the cosine of beta minus alpha is going to be 56/65. Okay. Problem number 5. Find all solutions from 0 to 2 pi of the equation sine of the sum of x plus pi over 4 plus sine of x minus pi over 4 equals -1. Okay? So we're going to go right to the sum and difference formulas. So we'd have sine of x cosine of pi over 4 plus, I get a little squeeze for room here, cosine of x sine of pi over 4. Okay, that's just this first part. Okay. Now I'm going to change colors because I'm going to run out of room. So for the second portion here, I'm just going to kind of half it down here. The sine of x, so we're going to have sine of x cosine of pi over 4 minus sine of pi over 4. And still didn't leave myself enough room, did I? So let's move over a little further. So sine of x cosine of pi over 4 minus sine of pi over 4 and cosine of x equals -1. So now we just got a lot of simplifying to do. Okay, so sine of x cosine of pi over 4. Well, that's going to be square root of 2 over 2 sine of x. Okay. Well, here's a positive cosine x sine of pi over 4. Here's a negative cosine x sine of pi over 4. So those two are going to be gone. So I've got plus square root of 2 over 2 sine of x. Okay. So here and equals -1. So when I add those two together, square root of 2 halves plus square root of 2 halves is just going to give me square root of 2 sine of x equals -1, which means the sine of x, when I divide, I'm going to get negative square root of 2 divided by 2. So x is the inverse sine of negative square root of 2 divided by 2. So I need all the values between 0 and 2 pi that have a sign of negative square root of 2 over 2. Well, square root of 2 over 2, that puts me in my pi over 4 group. It's negative, so I got to be in the third and fourth quadrant. So that's going to give me 5/4 pi and 7/4 pi. Okay. So taking the sum and difference formulas and applying it to solving an equation like we had in the last section. All right, number 6, prove. So this is proving or verifying the identity, which means we're going to work with one side, leave one side alone. Okay, so let's work with this. Tangent of pi over 4 minus theta. Well, the formula says that that'd be tangent of pi over 4 minus tangent of theta divided by 1 plus the product of the tangents. Tangent pi over 4, tangent theta. And now we're going to simplify. Well, tangent of pi over 4 is 1 minus tangent of theta divided by, If this is 1 times tangent of theta is just tangent of theta. And just like that, we are done. Okay. So just using the tangent of a difference formula to verify that the tangent of pi over 4 minus theta is 1 minus tangent theta over 1 plus tangent theta. Okay. And last page. Just something to think about. Okay. The best way to get better at math is by doing math. Not watching it, not listening to it, but actually doing it. Okay. Think about baseball. You could sit and watch somebody hit a baseball all day long, but you're not going to get any better at it until you get in there and start taking some cuts. Okay? So we'll see you in class tomorrow.